And cleaning up, I will multiply top and bottom of that big nasty black fraction by root x plus 1, and I think I get this downstairs. 4 times x plus 1 to the 3 halves. I think, however, upstairs what I get is a 2 times x plus 1 times 10x plus 4 minus my 5x squared plus 4x. Which is some stuff over 4x plus 1 to the 3 halves. Let's talk about the stuff. I'll close my pen. If I were to FOIL out, would you guys not agree that first times the first is 10x squared? Double it gives you 20x squared. Minus 5 of them gives me 15x squared. Would you not agree that the outside times the outside plus the inside times the inside is a 4x plus 10x? That's a 14x. Times 2 is 28x.
Plus 4x.
Minus 4 is 24x. Now the last is a 1 times 4, which is 4, but double it, you get 8.
Should that be a plus?
Join 8.
It should be plus 24x. Plus 24x.
Oh, yeah.
28.
You know what? I agree with you. Outside times the outside plus the inside times the inside is 10x plus 4x, which is 14x. Times 2 is a 28x, but minus 4x is going to be 24x positive. Thank you. You guys, I just exhausted all possibilities. The numerator doesn't factor nicely. So we would do. Use a quadratic formula. And I think that the zeros of my numerator can be obtained by looking at x being equal to the negative b plus or minus the square root of b squared minus 4ac. Okay, you guys, it's too late in the evening. I'm too tired.
Got it.
That's a negative 24 plus or minus the square root of I have no clue over 30. I really don't.
96.
Is that 96 on me? Okay.
And it's 4 root 6. Yes.
I agree.
Thank you.
All over 30. But that's nothing more than a negative 4 over 5. Plus or minus a 2 root 6 over 15. You guys, I'm getting too tired. Can we just stop for just a second and just, without a calculator, analyze this? I think root 6 is bigger than root 4, which is 2. So I get a 4 over 15. But negative 4/5 minus 4 over 15 is, shoot, less than negative 1. It's outside my domain. But I think negative 4/5 plus 2 root 6 over 15 is bigger than negative 4/5, which is in my domain. And so I think that tells me that I've got an inflection point at that negative 4/5 plus 2 root 6. I can't read my own writing. I said negative 4/5 plus my 2 root 6 over 15. But clearly with my second derivative function, if I plug like a billion in for x, a billion, that dominates everything. I think everything's positive. I'm concave up. I think if I chose something really close to negative 1, actually, can I just cheat 1 minute? 1 quick minute. For negative 1, that's 15 minus 24, which is negative 9.
It's not defined.
I know, but if I'm really, really close to negative 1, just slightly bigger than that, but really close to negative 1, that's close to 15 minus 24, which is negative 9. Negative 9 plus 8 is
Negative.
and Donald's always positive. I think concave down. I'm tired. I don't want to use my calculator.
Wait, I just want to make sure. Wait, then where'd the negative 4/5 minus 2 at 6 over 15 go? Or is
That would be
that
less than negative 1, which is outside the domain of my function.
I see.
I just simply claim I don't care.
Okay, gotcha.
I'm just being lazy.
If let's say the thing under the radical was x plus 3 or something, then would we have to figure out exactly where it
Yes,
is to figure out?
because I think this value is gonna be bigger than -3. I don't have to worry about it, yes.
Okay, alright.
You guys, let's put everything together. You know, moving just to the right of -1, actually between -1 and 0, my function's positive. I'm above the x-axis. But I'm initially increasing up to this particular local max, after which I'm decreasing until I hit the point whose whose x-coordinate is, I forget, is that -4/5 plus 2 root 6 over 15, comma, I don't know what, I'm too tired. After which I still decrease up to an x value of 0, but I'm concave up. After which I'm increasing, but still concave up. Somebody tell me how I algebraically locate the position of the oblique asymptote. Thank you. What oblique asymptote? I think since I concave up, I'm going to continue to change like that. I agree. It's not a rational function, but the degree upstairs is exactly more than downstairs.
Yep. Does it sort of have like a parabolic asymptote where it sort of hugs the x squared?
What a really good question. No.
Why not?
Because I think as x increases that bound, I think the way this function is behaving is the same way as y equals x squared times root x, which is the same thing as x squared times x to the 1/2, which is the same thing as x to the 5/2 power. I think at extreme values of x, you don't need to know this. I think that's how the function behaves. So if you want to find an asymptote, fine, there is one. It's just not an oblique asymptote, which is a line. It's a non-linear asymptote.
Okay.
Question. It keeps doing the imaginary. How would we? I understand we don't have to worry about it here, but it's like graphing an imaginary part.
Oh, you know what? That's a really good question. Everybody, everything on the board is completely wrong. It's completely wrong because I made an assumption. I made an assumption that x and y are real numbers. Now, if x and y represented complex numbers, then I think x is a complex number requires 2 dimensions. I think y is a complex number requires 2 dimensions. I think the graph of this equation really lives in 4-dimensional space. And what I've drawn on the inkboard, making the restriction that x and y are real numbers, is nothing more than a 2-dimensional cross-sectional slice of a 4-dimensional surface. So David, I neglected higher dimensions. I only considered when x and y is a real number, what the heck this graph looks like. But if you want to talk about higher dimensional space, we can talk about the surface in 4-dimensional space.
How would you draw the graph in 4 dimensions?
No. One word, flatland. I can if you allow me to use my computer because it's year 2013. I have the number crunching capabilities to do that. I really do.
You have that nifty program you showed us back in trigonometry that graphed like a box in like 4-dimensional space.
Yeah, do you want to see one?
Yeah.
Have we talked about flatland?
No.
Yes, yes.
Well, in video game format.
Video game?
No, we
What,
didn't.
what,
We
what,
didn't
what?
talk about
Let's
flatline.
compare it to video game.
Never watch the video flatland. Don't
I
do that.
watched it, it was awful.
It wasn't awful.
Yeah,
It was
the
just
voices, and like,
ridiculous.
it was
It
really
was horrible.
sexist.
hideous. They should never
It
send
was
us
like all the females are lions, and like,
No, that's part of the true story. And so you can say, is the author a sexist pig?
yeah.
Or was he trying to portray in 1880s English culture how women were treated poorly?
I don't know, he was.
You what?
I think it was just very sexy.
Do you really?
Well, because he was one of the men who lived in that era. Why shouldn't he?
And also
be
he was a
like
mathematician.
everybody else.
I resent that. I assign a letter grade to your name again.
Oh, no, he's a clergyman. So
Actually, he was, yeah.
That's even more so.
Bubbles.
Yeah, like I'm
But you know what? Since in the book you also talk about how horrible class structure was,
Oh,
and he did it
okay.
sarcastically, then maybe this suggests perhaps the attack on women was more of an attack on how the English society treated females. I'm not answering the question, I'm just
How
saying.
was he a
No, I
Catholic
understand.
priest in the 1800s after being killed?
He was a Catholic priest?
But not Catholic priest, well, he wasn't Catholic, but.
Well, I just assumed he was,
Clergyman.
angelic.
Yeah.
I could be wrong.
Anglican?
Anglican, yes.
Angelic.
Sorry, he's a different for English. So you guys, yes or no? I've talked about what happened in Flatland in terms of visuals.
Yes.
Okay. What happened? I don't see anything.
You might not have been here. That might have been that day that you were gone. Yeah.
David, you missed a day?
I know.
I don't remember that.
I was sad.
It was the day after we got our exams back.
Yeah, that's the one reason I still have it.
Oh, you guys, I don't know where to find this. Hold on a second. Ellipsoids. Ellipses.
There's no way to just input a function?
Hundreds of.
I don't want to write one. It's going to take too much time.
Oh, you can't just punch that one in? What happens?
Oh, there's a nice example. Here's a four-dimensional surface coming in and out of our three-dimensional universe.
A what?
Over time. So technically speaking, this has got 5 dimensions. 4 visual dimensions and 1 dimension is time as it passes through the universe. Just like the sphere passed through the square's universe.
Where is the fourth visual dimension?
No, you can't see it. You're just a 3-dimensional creature. I'm showing you 3-dimensional cross-sectional slices of the 4-dimensional object over time as it passes through the universe.
Oh, and time is that fourth dimension?
No, time's the 5th dimension.
So where's the fourth one?
You can't see it because you're a 3-dimensional creature.
Yeah, you're not meant to comprehend.
Just like
Wait, I
Nabil.
don't get it. So how is that graphic? That's not graphic in a variable.
Quite the contrary. Look at the look at the square living in this 2-dimensional space. As a sphere. Whoa, that was not metaphoric. As a sphere passes through its 2-dimensional universe, I can just graph these circles with bigger and bigger radii, then smaller and smaller, and poof, disappears out of thin air. Just like this 4-dimensional surface, you can see a 3-dimensional surface popping up, getting bigger and bigger and bigger as it passes through my 3-dimensional universe, and then goes away from it.
That's
Yes,
crazy.
I know. And I can go in a higher dimensional space. In the Math 33, we will.
What happens?
That's crazy.
What happens when you plug that into there?
Then I get a 4-dimensional surface that kind of cuts through our universe in a very strange way. Actually, it's worse. Because this picture I had in the middle board is actually not even a 3-dimensional cross-sectional slice of the 4-dimensional object, but only a 2-dimensional cross-sectional slice of the 4-dimensional surface. It's
So,
even
so
worse.
is that like a circle in the 10th dimension?
It's sort of, something like that, yeah.
I'm so confused.
Do you have a graph of the ant thing you were telling us about? I don't remember what it's called though.
Oh, the Delia.
The one?
The Delia.
Yeah, that's
The deal?
The Delia.
Remember
Well,
you
where
said
it-
that the
Oh,
ant,
the,
you like melt the glass or
flying
something and
bottle.
the ant can move.
Oh, the
it.
time bottle.
Yeah.
Wanna go grab it from your office?
I was just wondering if you
Google
had a
it.
graph.
Take a break.
Just Google it.
You know what happened?
It
Did
broke.
I brought it to one class, I handed it around, and a student passed it back to me, and he poured water in it.
What?
So it took me 2 weeks, just the other day, I finally got all the water out. I tried to heat it up with a hair dryer, but it didn't work, so I just put it on the windowsill for like days on end, and it finally evaporated now.
Did you give him?
I can bring it back to campus.
That was like the biggest cliffhanger the whole time.
Oh, was it really?
We thought you were gonna see it dropped and it broke.
Oh, no, I'll be devastated, no. You know,
Would you like punch him or something?
no.
That's like Chuck and
You know, a few semesters ago when I taught Math 33, my students bought me gifts at the end of the semester, and they bought me a scarf that was sewn as a Mobius strip.
Oh, God.
And they had a matching beanie cap that's a plain bottle. To this day, for me to come to work, I do come to work with it every once in a while, but I have to hide it in my bookcase so my wife doesn't see it because she refuses to have me wear it because she thinks it's way too nerdy.
Isn't that really annoying though, the
What's that?
scarf? That would bug me so much.
It is so cool. It's so
Really?
He doesn't make plain bottles, right?
Yeah, okay, that's what we're talking about.
Good.
Take a break.
I'll bring it in when I'll bring it in now. That's cleaned up. Oh, sorry. Oh, shoot. We had 3 examples in 1 hour.
Nice.
That's a record
That's
for
pretty
us.
good.
I hope it's enough to get you guys started. But that's really what I kind of expecting for you guys on I don't know, help me with this. Should I do a take-home quiz or an in-class quiz next Wednesday?
In-class quiz next Wednesday instead of the test.
Whoa. I asked, should I do a take-home quiz or an in-class quiz next Wednesday?
In-class quiz. In-class quiz.
Thank you. Neither, because we have our fourth exam. Yeah.
Extended.
There you go, extending.
Can't you give us a take home this Wednesday, like today?
That's a genius take-home exam.
That's so funny, Chris, just like that. That's a funny idea. All right,
There
take
was
home.
an episode of Futurama where they had the fourth dimensional stuff going.
You guys,
It was the whale going through the fourth dimension and third dimension.
while we're doing that, I
Watch
messed up.
Futurama, it was a huge
Oh, yeah, I haven't seen any of the new ones. Are they any good?
The new one?
Yeah.
I haven't seen that, I just turn on the TV and whichever one's on.
I used to watch that back in the 90s, like.